I'm Cheuk, and welcome to Baopai 2021. And so for all the information that you want to get, like all these slides that you can actually get from the link above, that's slides.com. That's the link for getting all these slides. Also, I'm sure that a lot of you will have a lot of questions afterwards because this talk is slightly technical, but I'm trying to just give an overview. So if you want to have more in-depth information, please feel free to reach out to me. You can send me messages on Twitter. You can also see, the code. You can find it, from GitHub and all these things. So please, if you want to know more, get in touch with me and I'll show you. So first of all, I'm Cheuk, and I love open source. I've been involved in a lot of open source projects in the past, and now I'm very lucky that I can work for the open source community in Terminus DB. We have a very good team. We do a lot of awesome things about graph database, and also Terminus DB is is of course it's open source. Also, it can do revision control. It's a graph database. So a lot of examples that I use today will be actually from Terminus DB. So again, if you want to know more, please get in touch. Um, Also, I love organizing Python events. So in the past, in last year, I've organized EuroPython, PyData Global, and also Pyjamas, which is a 24 hours fun conference. This year, of course, EuroPython is happening in July again, and also we hope to have Pyjamas back. PyData Global, it was a success. We may have it back, but not sure yet. Also, I stream on Twitch. So if you want to know, don't want to know more about like Python things, because I talk about Python, I give tutorial, I just, do things that I like in Python on Twitch. So if you want to watch me, please feel free to follow me, and you will get notification when I go online. So about this talk, of course, graph database. So what is a graph database and why? So I'm sure that a lot of you already know, have some knowledge about database, how to make query, how to use database. You may have experience using some more more popular database nowadays, which, for example, some relational database, a SQL-based database, that everything is stored in tables, and all records would have a key, right? And then you would link all this information in different tables using key. So that's how we store data. Kind of, there's a big history of that. That's why a lot of companies still doing things this way, but it's not necessarily the best way. In my opinion, there's much more other ways that's more interesting and more useful. So we'll look at it today. Um, First of all, there's a little bit of the history of databases, how it evolved. Of course, at the beginning, people are just storing sort of the very raw form of how to store data. Is kind of like a dictionary. You have a key, you have a value, so it's kind of like records in a library or something, right? So you have a way to represent a unique way of representing this information, and then you just find it by it. So it's a key value pair. Um, and then, it's not enough, right? So that's why we have this relational database that's SQL-like, and uh, but of course, company are expanding it a little bit. For example, Mongo, and they have also this flexibility of expanding a little bit, so that you can also store things as things and relation. It's still kind of having the relational database structure in mind, though. Of course, in recent years, something that's got really popular is graph-based data model, which I think some of you may already heard it. Like the one of the most popular open source one will be Neo4j. That again, things are stored in kind of triple, uh, that we will also talk about more later. That things stored in as object and relations, right? But even if there's a very simple concept, it could also be a lot of different way of doing it. Of course, there's other things that if you are a kind of in the kind of data community, in the graph data community, you may have heard about RDF, which is kind of a way of storing data that is very structured, and everything is object and with the type in the mind, but that's still not the most flexible way of storing things. So in Terminus DB, we use something called OWL, which is Web Ontology Language. Yeah, it's quite a big topic, so I won't be able to explain a lot today. But basically, it means that everything is an object. They got their own type. They also get their own property. So we can also define different basic data type as well. We can define that we have a string type, we have integer type. So it's very like kind of objects in Python. So you will see the similarity in a bit. So so why we invented all these like new models, right? Because it's much easier to interpret. So I think some of you may already have experienced that when you are trying to for example, if you use Django, right, you prefer to build a model in Python rather than writing your own SQL query. That's why you use these tools to help you to avoid making query directly rather than you would love to build a model. So why we have to do this interpretation and make a change if we already use a database that we don't have to use SQL, we already store things in a model that is very similar to how we build the objects in the program. That is like a much better way. So it's easier to interpret. You don't need the middle layer to do the translation. Also, it's more similar to real world entities. So, well, in our real life, a lot of relations that you have, for example, people that you have relations with, that is not going to be nice represented in a table. I will make an example in just a second. So storing things in relations actually is much better. Um, Also, there's more clear definition of object structured. You can define a schema before you store things. So if someone break the rules, they don't follow the schema, they can't really put the data in. So it's actually a better way to govern your data, right? To make sure that everything is in the correct format rather than having a big mess and then you realize that the data is not usable at the end, which is a horrible thing to do, right? So for example, here you see that it's kind of, well, it's very similar to what you are familiar with. It's a table, right? You have the key on the left hand side, which is the person ID. So that's the primary key here. Um, so we have a few columns. So name, date of birth is quite straightforward, but we have the mother and father column, and there's some numbers there. Some of them are null, which is a bit strange. So what does that mean? Can you figure it out? Yes, you are right. It's a family tree. But if you look at this, it kind of takes you a while to figure out what does that mean. You only see that, well, it's about some people because it says person, right? And also their names there. That's quite familiar with everyone. But but then like when a mother and father column is kind of get a bit frustrating because it's a number and you have to really map it to see like, oh, number two. So number two is Mary, so Mary is John's mother. Okay, you still have to spend some time to figure it out. But if we store data in this format, that is very visual, that is very straightforward, that you just follow the relations of John and then follow the relations of mother, and then you'll find Mary. You can even trace it one step backward to see like Mary's mother is Patricia, so that's John's grandma, maternal grandmother. Also, you can also color code your the person with the gender, so you kind of it's very obvious that for the parents, like which one is the mother, which one is the father, is very obvious as well. So it really makes things very easy, very intuitive. So why don't we just store data all the time this way? This is much better, right? Um, so again, like if you look at the query, so this is all we want to avoid, unless you're a data scientist, but you still hate SQL secretly. I know because I was a data scientist. Because sometimes you just want to do some data manipulation, and SQL is kind of in the way. It's kind of you have to think things like a table. You have to make millions of joins, aggregate, join it back to itself to carry out some kind of figure out some calculations, some relationship. That's very tedious. You can see here there's, well, a few lines of SQL, but you always have to select the table and then you have to, join it back. For example, if you find a grandmother, you have to make a join back to the table itself. It's annoying, right? But well, this is the example of Terminus DB. We use a programming, we use a query language called Waco, which if you use it directly in Python, it's just like manipulating some object, right? So this is kind of very similar to doing some modeling in Python. If you have experience using some modeling in Django, you would see what this means, or even like other tools that you can build a kind of object, a data model. This is how we do things. You just kind of call this triples. This triple all represent a relation, so it's kind of like the 2 points of a relations and the relations in between. So there's three things, so that's why it's called triple. And for example, you can see this person's mother is what V means variable, so we just want to find any person, right? And then the mother, so it will be returned as a variable. So it's just kind of like it's very intuitive. Well, it's kind of, well, at the beginning it's not that easy, but after that, when you get used to it, it's quite intuitive and it stick with you all the time. So um, storing data semantically is also an advantage because, as you see before, that we can also define the type of the object that you store. For example, a person, we create this kind of, it's like creating a new class in Python that we have this person class, so every object in there is a person. But we can also define some data type. For example, a date of birth is a date like daytime or date, right? So you can define the type of that. Or age is a integer that's not negative, so you can define age as a non-negative integer. So there's no mess around with all these data formats. Remember, in SQLs, a lot of time you retrieve some numbers. It can be cast as a string, can be cast as a number. So sometimes it kind of make a big mess because you remember some IDs, they may start with zero. So if you accidentally cast them as numbers, your trailing zero will be all gone, right? So that's a nightmare that I have to deal with when I was a data scientist. I really hated those. Um, so yeah, so you can see that well we have this well, I won't dive into the detail again, but we have this involvement from very simple key value pair into a very sophisticated kind of type system here. So how do we use it? Um, so our graph is well, like I said, I can't really cover all this deep dive information. It's a really big topic. It spends some people will need to spend some time to get familiar with it, to study it. I'm not an owl expert as well, so it's quite difficult. So we decided to, of course, Terminus DB is based in the owl graph format, but we won't expect everybody to write owl. So a lot of the thing is heavy lifting is done in the background. So we kind of, I will actually give you a tool later. So we kind of build a lot of tools to help people to build their schema, build their model using even GUI interface or do it directly in Python or JavaScript. So it's much easier. You don't have to really know OWL, but it's good to know that OWL is the driving force of how this like type model, how all these um, data are stored. So you can see that, for example, anything is a relationship. Like I said, is the two part of relationship and what is the part of the relationship. So a lot of them would be if there's a property there, then a property will have a domain, which is what objects they're describing. And for the domain, they will have range, which is for the property, they will have the range, which means that what type of data they are storing. Also, in OWL, we can support subclass. So if you if you have done some like kind of subclass in Python, it's not an alien. Idea is exactly the same. That subclass is basically a smaller subset of the class. So it also belongs to the class, but it's kind of more specific, belongs to this subclass. Kind of like if you have done some biology, you know how to you do this kind of or no uh, animals. You kind of divided it like mammal is actually part of the warm-blooded animal, and it's kind of like you have a big class which is animal, and then you have mammal which is a subclass. So it's kind of like that. um okay. I don't want to make things more complicated. I will give you a demo at the end so everything will be more clear. But the advantage of why we do this, like why we store things in a graph format, another advantage that come with it is that we can store data like Git, because um, the database itself is also a graph. So if you have some knowledge about how Git work, you may know that actually in Git you have all these branches, and for each branch you have different commits. They link to each other, kind of like a graph. So we can store data this way and allow you to do things that is like Git, which is great because like we love Git because we can have really good collaboration tool. We can back up. We can avoid all these like final version CSV, final, really final, approved CSV that is really confusing. Which is the real final version? Because I don't know. I just get all these CSV from emails, and sometimes it's confusing. Sometimes people miss the email and they thought it's a final version, but they have a final version that they should receive, but they didn't. No, don't do that. Just do things like Git. Everybody just push their work on a hub, and then everybody can just get the latest version by just clicking a button to pull it back. So which is great. You can also roll back if you don't like, if you think someone made a mistake. You can also go back to the one that without the mistake, and you can branch it from there, start all over. Well, you don't have to start all over, but start over from there. Um, so yeah, the database is a graph, so we can do all this Git magic. Where Git is a very good tool. You can think that why I just store my data on Git? Well, yeah, but Git has some limitation. There's like the size of the file that you store. Also, like I said, you don't use this like kind of object related way of storing data. You can try to store your CSV; it will work fine. But CSV is is convenient to share it around, but it's not good in terms of visualization, right? It's still a table. So it doesn't get the good things of the both world. Um, and also, you know, if you want it to be very efficient, we need to have some tool that works like Git but store things in a graph format. So here's how we do it in Terminus DB. It's just like it that we have layer builder. So every time you make a commit, so this is how you make a commit. You would add a layer that basically is two in one. So there's two layers that's added, saying that what is added to the graph, what is deleted to the graph. And then we will have a new head that's pointing to that layer. So every time if we want to know whether we have something in the graph, we just look back to see whether this information is added or whether this information was added but deleted. So if it's deleted, it's not there, right? Unless it's got added back in. So it's very easy to trace back to see what is in the graph, what is not. So it's how you make a query. Yeah, you can share and collaborate your data because the GitHub can do that with Git, then of course we can do that. So we can have a better data op for machine learning. It's easier for the whole data team to collaborate, or kind of having a way to control what is the experiment, what is the production. You can easily merge your experiment back to your production if you want an update on your production pipeline. Um, so yeah, that's much easier, and well, anybody can do that, right? That's much better. You don't need a whole team of data engineer to like move things around to make backup and spending more time on that. So Terminus Hub, which is what we also provided with Terminus DB, is free to register. Of course, it's kind of like GitHub, right? You can still have the enterprise version, which would cost you some money, but everyone can just register for free and use the free version with already a lot of possibility to do things. Okay. Um, so let's do the demos. I have a few minutes, so let me quickly show you, and you can see what I mean. Um, so first of all, this is Terminus DB. This is the interface here. Like I said, there's Hub. I have already logged into Hub, and then you can make a clone. So I will clone this bank example here. So just like your Git, so you get GitHub there, you could just like clone it, and then now I've cloned it with just a button. I've already done it. You can see that there's a lot of commit here is the previous owner Gavin has done some changes to it. Every time everything is logged, you can see the commit message here, so you know that what has been done, and you know what to roll back, or someone did something, you know what that person has done to update your database. So you can see here that we can have this. This is actually the schema here. So you can see that you don't need to write out. Of course, you can still write out, but you can actually see it as a GUI. So you can also add things here, change it. Now it's very simple because this is just a basic tutorial. We have bank accounts. That's all we have. And with the bank account here, we have three accounts here. We have Mike, Jim, and Jane. If we look at it, everybody got a balance and an owner, but there's a mistake here. So Jane's account, the owner is Jim. That's wrong. Jane should own her own account, right? So let's come here. I've created a Jupyter Notebook. Jupyter Notebook is, we can use the Python client here. Python client work perfectly with Jupyter Notebook. You can see that there's a lot of things you can do here. For example, you can here that you can actually you see that we have connected to the database. We just need some information here that I won't go into the detail, and then we fix the bug. So you see that all this model is done kind of with a Python object and their methods, and then you just put in some information here and then use the execute to put in the clients, then it will update it. So now if we have a look here, we refresh here, that you see that So take a while. So maybe it's too small for you. So now it's owner is called Jane. So that's what we want. Good. So now let's do something else. So for example, I base in London, so I want to make a London branch. So now here, if you see here that we only have the branch main here, but if we refresh it again, so you will see that I have the ability to change branch here. I have the London branch here. So it's really like it. And now I can add myself to with some money in the London branch. So now I am in the London branch record here. So branch, now we have, well, we look at here so that we are in the London branch that I've created Cheuk's account here. But if we go back to the main branch here, that, yeah, Cheuk is not there yet. I'm just fixing the bug. So what should we do? So it's very easy. So we just need to check out to the main branch and then add it back. So I would try to show you here with our GUI interface here. We can merge branches. So merge. And then what we want to do here is that because now we are in the London branch, so we want to merge into main. And then I will say that update main, right? Okay, so merge. Yep, I've successfully merged it. So now if we are in the bank branch, if we have a look at the home, so we see that, yeah, the newest commit has been added. So Cheuk is here, so you can see the detail here as well, which is great. So also what is good is that I can make some query in the Jupyter Notebook, and then you can show it in a pandas format. You can also show it in a graphical representation. You can see that Cheuk got some money, and then Jim has not that much money, and then Jane got lots of money. So yeah, so this is really good. So if you're a data scientist, if you love Jupyter Notebook, this is a very good tool to have. So um, I think that's the end. You got an idea. So I'm running out of time, so I'm just going to show you that if you want to know more, feel free to contact me on Twitter, or you can actually join our community at the end, like here at the link at the bottom. There's our Discord community. You can join and talk to not just me, but also the developers, the whole team. Um, so yeah, thank you so much for this tutorial. This talk. So I think that graph is a very good way to store data, and I hope that you're interested and you explore maybe not just Terminus DB, but also other graph database as well. So let me know what you think. And thank you so much. See ya. Bye.